Hi everyone, in this video we are going to solve another Leetcode problem which is called as Longest Palindromic Substring. This is a Leetcode medium problem. If you are new to my channel then welcome, and if you have previously watched my content then welcome back. I am Radhika, this is my YouTube channel DataZard, and without further ado let's jump into our problem. So the problem states that we are given a string S and we need to find the longest palindromic substring in this S. So if we have BA, BAD, then the longest palindromic substring could be either BAB or ABA, and this is what we have to find. Before diving into the solution, let us first understand what is a palindrome in case you don't know about it. Palindrome is any sequence. It could be of words, it could be of numbers, which is read the same way left to right or right to left. So if we have a word LEVEL, we read it the same way forward, which is LEVEL, and backward, which is LEVEL. Similarly, if we have number 1221, then it is read the same way in the forward direction, which is 1221, and the backward direction 1221. Such numbers, they are called as palindromes. The simplest way to solve this problem would be brute force. So that will be, if we have string ABABA, then what we do is we form all the substrings that can be formed with each character. So like with A, we can have A, AB, ABA, ABABA, like that. And then amongst these substrings, we decide which one is a palindrome and which one is not a palindrome. But this is not the most efficient way. The most efficient way would be to use an algorithm which is called as Manacher's algorithm. I hope I'm pronouncing it right. It is Manachers, Manacher's algorithm. And this is what I'm going to explain in this video. There are mainly three concepts that are involved in Manacher's algorithm. If you understand these three concepts, then Manacher's algorithm is piece of cake for you. So the first is called as transformations. So whenever we have to solve this problem, the first thing that would come to mind is our palindrome. It could be with odd number of characters, or it could be with even number of characters. Odd number of characters could be ABA, even number of characters could be ABBA. So instead of handling odd number of characters and even number of characters palindromes separately, what Manacher's algorithm suggests is we convert these into odd number so that we don't have to change our logic for odd number of characters and even number of characters. So for transformation, this is the easiest step. All we have to do is we have to add a character before and after each character. So our S is ABA. What Manacher's algorithm suggests is we add either a hash or a $sign. So I'm going to add a $sign before and after each character. So now if you count the string, length of string, it is 1, 2, 3, 4, 5, 6, 7. So we have converted it from 3 originally to 7 length. Now let us take our second string, which is ABBA. Currently it is 4 characters. I'm going to add $sign before and after each of these characters, and now if we count the number of characters, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have converted even an even length substring into an odd length, and this helps us to simplify the logic. So this is the very first concept of Manacher's algorithm. So ultimately what we are doing is adding dollar before and after each character of S. This is exactly what we have to do. Now let's move on to the second concept. It is called as expansion. Suppose we have string A, B, A, B, A. And now we have to figure out, if we take B as center, then what would be the length of palindrome? Longest palindrome here. So what we do is, we move one position to the left of B, one position to the right of B, and check whether the characters at these positions, they are equal or not. Yes, they are equal in this case. Can we go further on the left or right? We can go on right, but there will not be anything on the left, which means the longest palindrome that can be formed here would be equal to palindrome of length 1. Length 1 as in one character to the right, one character to the left of B. Suppose now we have to find at this position. Now what we will do is, we will again go one position to the left, one position to the right, and check whether these characters are equal. Yes, they are, which means we will have at least one. Let us move further. So 2 positions on the left and 2 positions on the right. Are these characters on these positions equal? Yes, they are. Can we go further left and right? No, we cannot. So the length of palindrome with A as center would be equal to 2. So this process is called as expansion. So essentially what we are doing is, we are moving equal positions on left and right of the center. Check characters at these positions. If they match, keep repeating. So keep going, one place, another place to the left, another place to the right. So what would be the stopping condition? So stopping condition would be when the characters do not match or the full string has been checked. So if you see here, we cannot go further than this. There's no second position here, which means that's why we said the longest palindrome that can be formed with B as center would be equal to 1. But here we were able to move 2 steps, but not beyond that. So either we find non-matching characters. Suppose there was a C over here. Then when we move one position to the left, one position to the right, they are not equal, which means the length of palindrome at this position would be equal to 0. But because it was equal, we were traversing the full string. So this is the whole concept of expansion. This is essentially what you will use during brute force. You're going to check for this as a center. So expand from center and go left and right and check whether we have matching characters or not. So this is the full concept of expansion. Let us move to the third concept, which is concept of mirroring. Suppose we have this string ABAABC. Now, the first thing that we need to do is transformation, and in transformation we apply a $sign. So let's do that quickly. So I'm going to add $signs over here, and now this becomes our new string. Now let me just add indexes. This is index 0, index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So these are all our indexes. The first step in Manacher's algorithm was to apply transformation, and then next we need to apply expansion, the second concept that we discussed. Why expansion? Because currently there is no palindrome that we have defined here, and if there are no palindromes, then we can't do mirroring. So let's expand on $. So these are my indexes. This is my string, and here I will add length of palindrome at this point, whatever length of palindrome is at each of these indexes. Now with expansion from here, let's start expanding. Can we go one left and one right? No, we cannot. This means the final length of palindrome with dollar as center would be equal to 0. So I will put 0 over here. Now, initially this was our eye. Now I will move our eye. So our eye will move to this. Now this is my eye. Let us also define our center and right boundary of palindrome. So I'm assigning it as 0 for now for both of these because we don't have any palindromes. These are for palindromes. Now with this as I'm again going to do expansion, and I can't do mirroring because we don't have a palindrome. So for expansion, I'm again going to go one on the left, one on the right of A, this index that we are evaluating. Are these characters same? Yes, they are. Can we go 2 characters to the left and 2 characters to the right? No, we cannot. There is no second character on the left of A, which means the maximum length of palindrome at A would be equal to 1. Why 1? Because we can go 1 to the right, 1 to the left. So this mainly represents the radius of the palindrome around this center. Now that we have got our palindrome, let us define it. So now our palindrome starts from here and goes till here. This is our palindrome. Now if we talk about the center of the palindrome, we have to update it. So we have to update these values. Center of the palindrome becomes index 1 because that's where the center of this palindrome is, and the right boundary of this palindrome is index number 2. Now again we have to move our eye, so let's shift this eye to here. Now currently we have a palindrome, which is this one, but the eye that we are evaluating, the index that we are evaluating, it is sitting on the right boundary of this palindrome. Whenever this happens, again we cannot apply mirroring. We have to apply expansion. The reason we cannot apply mirroring is because we are at the end of the palindrome. How do we know the things before and after it could be a palindrome? We don't have any guarantees. That's why we're again going to use expansion. Now I'm going to expand around this index. So going one to the left, one to the right, and checking these characters, are they equal? A and B, they are not equal, which means the palindrome, the length of palindrome with this second index as center would be equal to 0. Now let us move to this position. So I'm again going to shift my eye, and my eye becomes this. I don't have to change center and right because my palindrome still stays over here. Now with this as eye, again I'm going to use expansion because we have a palindrome here, but we are sitting outside of the palindrome. Our index that we are evaluating is greater than the right boundary of the palindrome. We are evaluating 3, but the right boundary of palindrome is at 2. In such cases also we can't use mirroring. So in this case, again expanding. So 1 to the left, 1 to the right, are these characters equal? Yes, they are. 2 to the left, 2 to the right, are these characters equal? Yes, they are. 3 to the left, 3 to the right, are these characters equal? Yes, they are. Can we go beyond 3? No, we cannot. There isn't a 4th character on the left. So the maximum length of palindrome which can be formed at B is equal to 3. So the palindrome center would be B, and we go 1, 2, 3 places, and this would be the right boundary of the palindrome. Like at index 6, this is the right boundary. Because the right boundary of new palindrome is greater than the right boundary of old palindrome. Right boundary of old palindrome was at 2. Our new boundary will be at 6. So we have to move our palindrome and update the center and right. So let's do that. So I'm going to clear out this palindrome. I'm going to clear out these left and right values. Now our palindrome would be this value, this big, and our center would be at index 3. So I'm putting index here. Our right boundary is at index 6. Now I will move our eye as well. So let's move eye to index 4. Now at index 4, we check, are we within a palindrome? That is, the index that we are evaluating, is it less than the right boundary, which is 6? Yes, it is. In this case, we can use mirroring. Only and only in this case, we can use mirroring. So now what happens with mirroring is, we first try to get the minimum number of, let me just write it down. In here, we will try to get the minimum length of palindrome. Now, how do we get this? According to Manacher's algorithm, the minimum length of palindrome would be equal to minimum of length of palindrome at mirror or r minus I, whichever is lowest. Let's think about this, why this formula and how this formula came up. When we are here, we know we are within a palindrome. The sequence of character, this is the center of palindrome, right? This is the current center. Now we know the sequence of character before this and sequence of characters after this would be equal. Because they are equal, what we can say is we've tried to find the mirror location of the current index. Current index is 4. This 4 is 1 to the right of center. So its mirror would be 1 to the left of center. So this is our mirror for I. Now, the length of palindrome at this location would be equal to minimum of, according to this formula, minimum of, what is the length of palindrome at location of mirror? It is 0. So minimum of 0, or r minus I. R is 6 minus I is 4. These indexes. So minimum of 0, 2, which will be equal to 0. Why we are not just getting the length of palindrome which was here as minimum length here? The reason being, we don't want to go outside of the boundary. Suppose it was 3 over here for some reason. If we try to get 3 places from this index, then we will be outside of the boundary of palindrome, and we cannot guarantee that this would be forming a palindrome. That is why what we do is we take minimum of whatever is the length of palindrome at its mirror and right boundary minus 1, because we want to be within the boundary, because we know only about the boundary. We don't know anything outside of this boundary. This will make more sense in coming indexes. So I'm just putting this as 0 because now we know the length of palindrome here would be equal to 0. Now let us move on. So I'm just gonna remove all this, change our I. So now our I would become index 5. Now again here we are going to check whether our I is less than right boundary, because that would mean we are within a palindrome again, and the sequence of characters on either side of palindromes are equal, so we can use this formula. Yes, we are within the boundary, and in this case again we are going to use this formula. Answer would be equal to minimum of, what is the mirror of this index 5? This index 5 is 2 on the right of our current center. So its mirror would be 2 on the left of the current center. So mirror would be this location. What is the length of palindrome at mirror? It is equal to 1. So minimum of 1 comma r minus I. So r is 6 minus I. So minimum of 1 comma 1, which will be equal to 1. Now this is the minimum length. What we are saying is this is the minimum length. There could be a longer palindrome as well. So after minimum length, we need to expand. That's what the algorithm says. So we don't have to expand on the first because we know it will be there because we are within a palindrome. But we need to expand from second position. So let's start doing that. Start expanding to second position from here, second position from here. Do they match? They don't. Which means the longest palindrome that we get with A as center, like this index 5 as center, would be equal to 1. Now again, I will shift my I and I will then calculate what is the longest palindrome at index 6. Now again at index 6, we have a palindrome, but are we within the boundary of the palindrome? Is our I less than the right boundary of palindrome? It is not. In this case, again, we can't use mirroring and we have to use expansion. So we are going to expand from here. 1 to the left, 1 to the right. These are equal. 2 to the left, 2 to the right. Yes, these are equal. 3 to the left, 3 to the right. Yes, they are equal. 4 to the left, 4 to the right. Yes, they are equal. 5 to the left, 5 to the right. Are they equal? No, they are not. So in this case, our palindrome would be equal to of length 4. 4 to the left, 1, 2, 3, 4 here, and 4 to the right, 1, 2, 3, 4 here. So this 10 position would be the right boundary. Now let me change our palindrome, because the right boundary of current palindrome is 10, right boundary of old palindrome is 6, 10 is greater than 6. So our newest palindrome has a bigger boundary, has boundary greater than the old one. So we have to move it. So let's do that quickly. Now our palindrome would be now with this as palindrome, our center is here. So now I have to update my centers as well and the right boundary. So center is at position 6, index 6, and our right boundary is at 10. Now again we will move our eye. So our eye is now standing here. Now again here we are going to check. We have a palindrome, we are within the palindrome because our eye is less than the right boundary of the palindrome. When this happens, we can apply mirroring. With mirroring, we first find out the minimum length of palindrome. So minimum length of palindrome here would be equal to minimum of length of palindrome at its mirror. What is mirror of A? This is the center of our palindrome. This index is 1 to the right of center, so its mirror would be 1 to the left of center. So this location. What is the length of palindrome here? This is our mirror of I. So length of palindrome at its mirror is equal to 1. So minimum of 1 and r minus I. So r is 10 minus I is 7. So minimum of 1 comma 3, which will be equal to 1. So we can say that minimum would be equal to 1. Minimum length of palindrome with A as center. It could be a bigger palindrome as well. Let's try to expand from here. We have only got the minimum using mirroring. So we expand 2 positions on the right, 2 positions on the left. Do we have a palindrome? No, we don't. These characters, they are not equal. So the longest length of palindrome that can be generated from here is of length 1. Now I will again move our eye. So now our eye is at location 8. Here again we will check. Is our eye less than the right boundary? Yes, it is. Our eye is 8. Our right boundary is at 10. So yes, this is true, and that's when we use mirroring. When we use mirroring, we first get the minimum length of palindrome, which will be equal to minimum of length of palindrome at mirror. So mirror for location 8 is location 4. Why? Because this location is 2 to the right of the center of current palindrome, so its mirror would be 2 to the left of palindrome, so it's this location. So this is mirror of I. What is the length of palindrome at mirror? 0. So it will be minimum of 0 comma r minus I. So r is 10, I is 8. So minimum of 0 and 2, which will be equal to 0. So now I'm going to add 0 here, and because it is 0, we know the left and right, they won't match even if we do expansion. So the length of palindrome is 0. Now let us again move our eye. So now I'll move the eye to index 9. Now this is where things become interesting. At eye, again I check. Am I within a palindrome? So is my eye less than the right boundary? Yes, my eye is 9, my right boundary is 10. I am within the palindrome. That's when we can use mirroring. With mirroring, we have to find minimum length of palindrome we can find. Minimum length of palindrome here would be equal to whatever is the length of palindrome at its mirror. What is the length of palindrome at mirror? This location is 3 to the right of current center of palindrome. So its mirror would be 3 to the left. So this is our mirror. Now this B is mirror of this B, and the length of palindrome here is 3 at mirror. Now we find r minus I. So 10 minus 1. 10 minus 9. So it's minimum of 3 comma 1, which will be equal to 1. So if you see, we are not copying 3 here. Why? Because if we go 3 places on the right, it will be outside of our palindrome, and outside of palindrome we can't guarantee. We have not seen these characters, so we can't guarantee that these would be forming a palindrome. That's why we are adding this r minus I condition, that either we get whatever is the length of the palindrome at its mirror, but if that length would exceed or go outside of our palindrome, then we will use r minus I, because we have to be within the boundary. And because of that, it would be 1 over here. Now from here we are going to check, we are going to expand. So we go 2 places on the right, 2 places on the left of this P that we are evaluating. These are not equal, it's A and C. In this case, the maximum length of palindrome that we can get is 1. Suppose we just blindly added 3 over here, then this would have failed. This is the important reason why we have r minus I here, and not we are just copying the length of palindrome from the previous steps. Now let us again move our I. So now the I becomes at location 10. At 10, I is equal to 10, our I is not less than right, it is equal to right. And in this case also we have to use expansion. Let me clear this. So for expanding, I'm again going to check whether 1 to the left, 1 to the right, are these characters equal? No, they are not, which means the maximum length of palindrome that we can get here is 0. There is no palindrome existing. Now we move to this location. This is our I. Again we check whether our I is less than right. Right is at 10, our I is 11. It's not, which means we can't use mirroring. So in this case we have to use expansion. So we expand 1 to the left, 1 to the right. Yes, they are equal. We can't expand beyond 2 on the right, so the maximum length of palindrome that we can get over here is 1. Now here we just move our palindrome, because the right boundary of our new palindrome is at 12, which is greater than the right boundary of the old palindrome. So I'm just going to remove this, and my new palindrome would be this. Now we have to shift our center and right as well. So our center now would become 11 and right would become 12. Now again we're going to change our I. So now our I becomes this location 12. Now with this location 12, I'm again going to check, are we within a palindrome? Is our I less than right boundary? No, it is not. It is sitting right at the boundary. In this case we have to use expansion, and we can't expand on the right, so the length of palindrome here would be equal to 0. Now that we have got the maximum length of palindromes that can be formed with these as centers, we can choose whichever is the maximum, so this, and then form the longest palindrome here and return the answer. This is the full concept. Now you would be thinking how the complexity went down from ON square to ON. ON square was for brute force, but for Manacher's algorithm it is O of n. The reason why this happens is because we are checking previous values and we are only expanding beyond these previous values, so like beyond the minimum length. So let me take another example. Suppose now this is our example. I have already written length of palindromes for a few of the elements just because it's the repetitive same process, but let us now evaluate the length of palindrome at I, where I is at location 7, index 7. Now our current palindrome is at index 5 and the right boundary is at index 10. This is our right boundary. So again, the index that we are evaluating is less than the right boundary. Because it is less than the right boundary, we know we are within the palindrome, and the sequence of characters on the right side of it would be equal to sequence of characters on the left of its center. So we are going to use the concept of mirroring, and we find the mirror of this location 7. So this index 7 is 2 to the right of A, so its mirror would be 2 to the left of A. So its mirror is this. This is mirror of I. Now according to mirroring, we can get the minimum length of palindrome by finding minimum of what is the length of palindrome at its mirror. It is equal to 3. So 3, or in r minus I, right boundary is 10 minus I is 7. 7. Minimum of 3 comma 3, which will be equal to 3. What does these 3 mean? This is minimum right now. It could be bigger because we are just playing within the palindrome right now. Minimum means it will, if we try to expand up to 3, it would still be a palindrome. Let us expand at position 4. So position 4 is this, and position 4 from left of this B is 1, 2, 3, 4, this B. Are they equal? Yes, they are. Let's expand to position 5. This is position 5 and this is position 5. Are these equal? Yes, they are equal. Position 6 on the right, position 6 on the left, are these equal? Yes, they are. So can we expand beyond that? No, we cannot. There is no position on the right. So the maximum length of palindrome that we can get from this is of length 6. So with B as center, we can go 6 positions to the right. With B as center, we can go 6 positions to the left, and this full will form a palindrome. Now, while finding this, did we expand to first position, second position, and third position? Did we do it? No, we just copied whatever we got from mirroring, and then we tried expanding from 4 to 6, 4, 5, and 6. We didn't expand 1, 2, and 3. So because we are not expanding these 3 and just using the concept of mirroring, this is bringing down our O(n) squared to O of n, because we are not expanding here. We are using the previous knowledge. This is the full working of Manacher's algorithm. Let us look at the flow of events, how this happens quickly. So if you look at the flow carefully, first we need to apply transformation where we add $sign. Then we need to expand till we get our first palindrome, because till we get a palindrome, we cannot think about mirroring. As soon as we have caught the palindrome, check whether the index that is being evaluated, if it is less than the right boundary of the current palindrome, because that would mean we are within a palindrome, and then we can check for mirroring plus expansion if this is true. But if we are not within the palindrome, if we are right at the boundary or outside of the boundary of the palindrome, then we can't do mirroring and we need to just apply expansion. After both of these steps, we just move the center and right if they are needed, if our new palindrome's right boundary is greater than the right boundary of the current palindrome. Always remember, after mirroring, we have to apply expansion. Mirroring will only give us the minimum length of palindrome, but there could be a palindrome bigger than this. So that's why we do expansion. And with expansion, we don't have to worry about it because we are expanding till the very end, till we know that it's not a palindrome anymore. This is the flow, and I'm going to replicate this flow in the code. Let's look at that. Now let us look at the code. First, here what we are doing is, if our string is of length 1, then obviously it's a palindrome in itself and we are just going to return that string. This is just an edge case. In this step, we are doing transformation, because now here we are adding the dollar values. Then we have got our new string and we are just getting the length of the string, storing the length. This is the center and right that I'm defining for our palindromes, and currently they are initialized as 0 because we don't have any palindrome. These are just max length and max center of the palindromes, the known palindromes that we have. This is just because we are within the loop and we can figure out which is the maximum length and update that rather than running a second loop over all the length of the palindromes that we have caught. So that's why I've stored these values. Now, while I is less than right, so this is the condition that we are checking. Is our I less than right? If it is, we first find the mirror, then we find this is our condition of mirroring. This is the length of the mirror and this is right minus I. We choose minimum of that, and that would be our P of I. This is just the minimum length. Beyond that, we need to expand. So after I have done mirroring, I'm checking for expansion. So here in expansion, I'm first checking, are we within the boundary of the palindrome? Because we can't go outside of this when we are checking the values. So are we within the boundary? This is what is being checked. Is our leftmost index greater than or equal to 0 and our rightmost index that we are checking less than our length of string, because we have to be within the string. If this is true, then we check, are the characters on these locations, they are equal. If they are, then we keep expanding. So we are increasing our P of I. P of I is length of the palindrome. These are the values, the digits that we were storing above our string. This is our P of I. This is what we are referring as P of I, the length of palindromes that we are storing. And these are our indexes, so don't get confused between them. Then here, if our right boundary of the new palindrome is greater than the current right boundary, then we are just shifting our center and right. This is exactly what I have mentioned here. And then here I'm just updating our max value. If I know that there is a newer palindrome which is bigger, then I'm just updating that so that I can just return on it. This is the final Python code. I hope I was able to explain you Manacher's algorithm. If you have any questions or any doubts, please put them down in the comments below and I would be happy to answer them. Thank you for watching. I'll see you in my next one.